First of all, both standardization and normalization are types of feature scaling. Let's see, what does feature scaling mean? In this example, we have a dataset plotted on a histogram. Its range starts around 20 and ends around 60. If we divide all the values by 2, we will change its scale from 20 to 60 to from 10 to 30. This is an example of feature scaling. Feature scaling can be done with multiplication, subtraction, addition, or division. In this video, you will know answers to the following questions. Why do we need feature scaling? Which machine learning models need feature scaling? What is normalization? What is standardization? And when to use which one? Let's continue with the question, why do we need feature scaling? Let's see this example. In this dataset, we have 3 columns, age, number of children, and income. If we feed this data to the machine learning model as it is, it will give more attention to the income column and less attention to the age and children columns, because the scale of income column is much larger than the other columns. That's why we need to have the same scale for all the columns. In this way, the importance of features will be decided in the training phase rather than according to their scales. If you don't apply feature scaling, then your model will be biased towards the features which have larger scales, and the model will not converge. As we answered the question, why do we need feature scaling? Now let's see which models need feature scaling. The first group is the gradient-based optimization algorithms. Here we have linear regression, logistic regression, and neural networks. These models use gradient algorithm in the optimization process. If we change the scale of our features, then the gradient algorithm will converge faster. The second group is the distance-based algorithms. Here we have KNN and SVM. As you know, KNNs decide according to the distances between data points. If you have different scales for different features, then it will be biased toward larger scales. And SVMs also use distances in order to have the planes between different classes. If you have different scales, the model will be biased again. The third one is PCA, Principal Component Analysis. This model is used to reduce the dimension of the dataset. If we have different scales, then the calculation of principles in order to reduce dimension will be biased. Tree-based and naive-based algorithms do not benefit from feature scaling, because in tree-based algorithms, the important is the comparison of data rather than the values. Also, for naive bias, we have probabilities, so we do not have interest in the values of the features. That's why these two kinds of models do not benefit from feature scaling. You can also check my Medium blog about this topic. I have written all the explanations with illustrations. Now let's dive into more details and see what are these two methods. Starting with normalization, we have these graphs here. The data has a minimum and maximum value, and when you apply normalization, its scale will change from its minimum to maximum values to 0 and 1. Normalization simply means to change the scale of the value to 0 to 1. This is done by applying this formula to the dataset. We subtract the minimum value of data from the data point and then divide by the difference between maximum and minimum values. This is our dataset example. We have applied normalization here, and as you can see, the range is from 0 to 1. Now let's move to standardization. The goal of this method is to change mean to 0 and variance to 1. What does this exactly mean? It will be better to show it on a 2D graph. This is a random data with the mean and variance different from 0 and 1 respectively. If we apply standardization to this dataset, it will convert into this. As you see, the variance of the data has been decreased to 1 and it's around 0, which means its mean is 0. Let's see it again. We have a dataset which have covered very large space. When you apply standardization, it will come around 0. Now let's see the equation. We subtract the value of the mean from the data and divide by standard deviation. This is our example. We have applied standardization to our data, and there is a big misconception about standardization. It's believed that when you apply standardization, the distribution becomes normal distribution. But as you see on the picture, when you apply standardization, the data doesn't become a normal distribution. Yes, the mean of the normal distribution is 0 as well, and the variance is 1 as well, but it doesn't mean that the distribution will change to normal distribution. Now the important question: when to apply normalization and when to apply standardization. The best approach is to try both methods and see which one is better. But to have a guidelines before starting, I can say the following. For example, you have an image data which has pixel values in the range 0 and 255. Then you can apply normalization here to have the range between 0 and 1. This will help to simplify the calculations and converge faster. For standardization, nearly most of the models benefit from standardization rather than normalization. And also, the important point is if you have outliers in your dataset, standardization is the better choice. In the code, you can practice standardization and normalization. I have provided the notebook and the dataset. You can download both of them and try it on your own. Here, we will start by importing libraries and the dataset, and we can see our dataset by using head function. It's clear that the scales are different for every dataset. I have used each column for practice. Here you see the histogram. The values start from 20 until 60. The first try of feature scaling is by dividing 2. The range have been transformed to 10 to 30. In the second example, I have subtracted 20 from the values, and the range is from 0 to 40. And here I have applied manual normalization by using the equation, and you can see the result. The range is from 0 to 1, as was said on the lecture. In the second method, I have used sklearn library. With the help of the function min-max scaler, the column have been normalized, and again the result is the same with the manual method. The range is from 0 to 1. And then I have used sklearn library again for standardization, and here our range is different because it's standardization, not normalization. Then the important example with 2D data to show standardization. Here we have a random dataset, and the second graph shows the effect of standardization on the data using scatter plots. You can also check my previous video, which is about activation functions in deep learning. In that video, I have answered the following questions. What are activation functions, why do we use them, and what are the differences between different activation functions? It's a complete guide and easy to understand. If you want more videos like this, don't forget to like and subscribe, and check the code on my GitHub page and the blog on Medium. Thank you for your attention and time.